Hello, welcome to my channel. I am Ameya, and today in this video we will be continuing our FEA methods, non-weak form weighted integral methods, and today we are starting with Galerkin method. In previous video we just started with this problem, okay, and we did the initial steps which we need to perform by approximation, residue, and finding the weighted integral form. I will be putting link of this video on the top. You can just click there and visit the previous video. In this video, we are going to start with the Galerkin method. Okay, so till now, we know that we have the weighted integral form. So this is the weighted integral which we found out this, and for Galerkin we need to decide what will be this Wi weighted integral. Okay, so for Galerkin the rule says Wi will be coefficients of Ci in equation y. Okay, so what we have to do is we have to go for equation y. We need to check the coefficients of C in equation y. So let us try to understand this. What is my y equation? So this is my y equation, and I am interested in these coefficients of constants. Okay, so in this case there will be 2w because we are solving it for two unknowns. So w1 when I is equal to 1, w1 is equal to coefficient of c2 which is x square minus 2x, and when I is equal to 2, w2 will be x cube minus 3x which is the coefficient of c3. So this is a coefficient of C2 and this is a coefficient of C3 that we are taking. Now we have to substitute this W into the weighted integral form. So for I is equal to 1, integration 0 to 1, you will take x square minus 2x into y. So that is C2 6x plus 2 plus C3 3x square plus 15x minus 0.3x minus 6. This we get from the previous video is equal to 0. Now what we will do is we will try to solve this in a calculator, taking C2 common, taking C3 common, and taking the constant. I have already uploaded video for this, solving these equations in calculator. I will be putting link at the top. You can refer that link to solve this in a calculator. If you put this directly in a calculator without solving it, simplifying these brackets, you don't need to do that, and that trick will help you to get the direct coefficients. So coefficients of C2 is 3.833 C2 plus 6.95 C3 minus 4.123 is equal to 0. You will label this as 1. This is my first equation which you get from Galerkin. The second equation is for I is equal to 2. So we will be substituting this. So integral 0 to 1, it will be x cube minus 3x. Y will remain same. So C2 6x plus 2 plus C3 3x square plus 15x minus 0.3 minus 6 dx is equal to 0. Again solving this, you will get second equation with two unknowns, that is 7.3 C2 plus 13.371 C3 minus 7.74 is equal to 0. You will give this to be equation 2. Now what do we have here? We have two equations with two unknowns. So you can solve 1 and 2 simultaneously. You can put these coefficients in calculator, that is also very easy, and you can directly get the value of C2 which is 2.64, and C3, which is minus 0.862. Okay, if you remember in previous video, we have found C0, we have found C1. Now you can substitute this into the equation of y. So this is my equation of y. I will try to substitute y is equal to 1 plus 0.1x plus 2.64 C2 into x square minus 2x minus 0.862 x cube minus 3x. Right, now we have C0, we have C1, we have C2, and we have C3. Now what the question says, we need to find the value of y when the x value is 0.2. So we will be substituting x is equal to 0.2 in this equation. So now we need to substitute x is equal to 0.2. So you will get the value of y for a value of 0.2 as 0.58. Just a second, let me erase this. This is 5. 0.58. What we did is we just substituted this 0.2 in the all x terms. We already have sorry, this C2 will not be there. I mistakenly written that. So this C2 will not be there. So we only have one constant x, and you will be substituting that x into the y equation, and you will get the value of y at 0.2, and we are interested in this value, and this value basically represents the value of y using Galerkin method. Okay, so only important thing which we need to understand is for Galerkin we take Wi is equal to coefficient of Ci constants in equation y. So from equation y you pick up the coefficients and then you put those coefficients as W1 and W2, and then you continue solving using the Galerkin method. Okay, so this is all about the Galerkin method. It's very simple. Just practice few more problems on Galerkin and you will get a complete idea how to solve this using Galerkin method. Okay, if you like this content, do subscribe my channel, follow my channel, and share a word about channel with your friends. Thank you for joining.